Okay, so number 19, you have 8a, 15a, and 17a. And the question at the top says, state whether or not the three given numbers could represent the lengths of the sides of a right triangle. So this is asking you to apply the converse of the Pythagorean theorem, which is if a squared plus b squared equals c squared, then it's a right triangle. So when we do this, remember it's going to be 8a squared plus 15a squared equals 17a squared. And so the variable involved doesn't really change anything. And so we end up with 64a squared plus 225a squared, which equals 289a squared. 64 plus 225 does equal 289. And so these are the same. And thus, this is a right triangle. And it turns out that 8, 15, 17 is a relatively common, what we call Pythagorean triple. And then 8a, 15a, and 17a is just a multiple. We're multiplying each of the terms by a. All right, and then also number 23. On number 23, you're given that a equals 18, b equals 1/3 a, and then you're asked to find c. Well, this is just asking you to do a little bit of algebra before you get started, right? If a equals 18, then b is 1/3 of that, so b equals 6. And then ask you to use the picture at the top, which says that c is the hypotenuse. So we just do 18 squared plus 6 squared equals c squared. And so that means that c squared equals, well, 324 plus 36, which is 360. Take the square root of both sides. And when we take the square root of both sides, the square root of 364 turns out to be, when rounded to the nearest hundredth, 18.97, which is your answer. And then from the extra section on the distance formula, you're given number 13. You're given that m is -2, -3, a is 3, 9, and b is -7, -15. And what you want to show is that m is equidistant. This is equidistant from this point and this point, which means the distance from a to m is equal to the distance from b to m. So you use your formula. Remember, your formula is this. Subtract the x's squared, subtract the y's squared. Remember, it doesn't matter the order because of the square is just going to turn it into a positive. And so you get d equals square root of, and so we want to do am first, -2 minus 3 squared plus -3 minus 9 squared. Well, that turns out to be 25 plus 12, which equals, or 12 squared, which is 144. Right, -5 squared, -12 squared, which is square root of 169, which is 13. And then I look at this one, and it turns out that you do square root of -2 minus a -7 squared plus -3 minus a -15 squared. So that's going to equal, well, -2 minus a -7 is like -2 plus 7, which gives you 5 squared, which is 25. -3 minus a -15 is going to give you 12, which is like 12 squared, which is 144. And so when we take the square root of that, we also get 13, showing that, yes, this is a equidistant. M is equidistant from A and B. And actually what it turns out is it's the midpoint of AB, which means on the line, if you connect A and B, it's exactly on the midpoint for this particular one. You can be equidistant from 2 points and not be on the midpoint. But if you're on the line and equidistant, that means you're on the middle point as well.